Alright, so I asked you to take out your blue sheet because we have gone over everything on this blue sheet with the exception of what's at the bottom here. So this is 8-8, your factor patterns. I am telling you now that if you don't learn these and memorize them, you will have trouble with Unit 9, which is factoring. Because this saves you time with factoring. And I will give you trinomials that have really big numbers in them so that you can't use the normal factoring patterns, or it's really difficult for you to use the normal factoring way, and you have to use the pattern in order to get there. And that tells me whether or not you recognize it's one of these special patterns and that you know how to use it. So we're going to start by multiplying these special patterns. And do you remember in your homework I kind of pointed out to you as you were working on Friday that didn't I say to star these? Because how are these different than all the ones that were above them? You got a binomial, right, instead of a trinomial when you multiplied it out. What happened to your inner and outer terms on these ones? They canceled out because you had a negative and a positive and they were the same thing. What do you notice about the binomial here that's different than like the binomial here? Well, the exact same numbers are in the binomials, right? But what's the difference between the binomials? There's a plus and a minus here. You're going to experience today what happens when there's a plus and a plus or a minus and a minus. If these are both the same sign, you're not going to get this. If they're different signs and you have the same exact things in the binomials, you will always get this thing here. Didn't both of these have a subtraction sign? And you will always have a subtraction sign because what's a positive times a negative? A negative. And that's why you will always have a subtraction sign. Then what kind of a number is 9 and 49? Perfect squares. Not square roots, but perfect squares, right? What's the square root of 9x squared? 3x and 3x. What's the square root of 49? 7 and 7. So if I asked you to go from here to here, you're going to learn how to do that in Unit 9. But in Unit 8, you're going to learn to go from here to here. And you can use a shortcut. You don't have to use FOIL or a double distribution. In other words, I should have to see absolutely no work for this one. Isn't that great? This entire assignment that you do tonight, I expect to see absolutely zero work. Odd but true that I'm telling you to show no work. If you show work, it tells me that you're avoiding learning these factor patterns, right? Of course, you could go online and copy the answers, right? But who are you cheating? Yourself. So, you know, it'll show up on your test when you don't know the pattern. And so same thing here, I would expect to see no work for this one. And notice again, what's 16 and 25? Perfect squares. What's the square root of 16s squared? 4s is here and here. And what's the square root of 25? 5 and 5. This pattern is called the difference of two perfect squares. Isn't that what you see? Anytime you have the difference of two perfect squares, you're going to apply this pattern. And so we're going to look at what some of these special products are, and you have them written down here. We're going to look at what's called the difference of two squares, is what I was just showing you. If you have two perfect squares and a minus here, it will pattern into the square root of each of these. Square root of these are a and b, so a and b go inside the binomials. Then you have a plus and a minus. If there's a plus here, you cannot, well, you won't get a plus here. And so we'll talk more in the next unit of what happens if there's a plus here. Then we're going to talk about squared binomials. So we're going to take this, only one parenthesis that's raised to the second power, and we're going to square that today. Notice that the answer is not a squared plus b squared. What's the answer? You have an a squared and a b squared in there, but what's in the middle? A 2ab. Oftentimes the answer that I get to this is a squared plus b squared. Because you don't memorize the pattern, you just assume that you square this and square that, but there's a plus sign in here. It's different than ab squared. If it were ab squared, power to power, you would multiply the exponents. But there's a plus here or there's a minus here. So let's look at our special products. And let me find my pens. Alright, so 8-8. This is probably, as far as I'm concerned, the most important lesson out of the whole thing. Special products. So the very first pattern that I talked about was the difference of two squares. You have to know what the name of the pattern is and what the pattern is itself. There's only 3 of them that you're responsible for, and let me just tell you that these never ever go away in math. I also teach pre-calculus, which most of you will take as a senior. You will have these special products in pre-calculus. You will have them next year in geometry. You will have them the year following that in algebra 3-4. If you get to calculus, you will have them in calculus. These never go away. So whatever you do in unit 8 and 9, don't think, I don't get this, so I'm just not going to learn it and I'll learn everything else. This will affect all your other classes. If you don't know this, you're going to have struggle in all of those classes because of it. All right, so the difference of two squares says that if you have a plus b times a minus b, you can shortcut your double distribution or your foiling by just saying it's the first term squared minus the second term squared. It's like a blueprint telling you how to do a shortcut. Memorize it. So let's practice. Well, I won't do an example yet. What if I had x plus 7 times x minus 7 without, first of all, I'm going to FOIL it just to prove to you that it does work in case you didn't pay attention to it in your notes. So let's go ahead and do a double distribution. So if I take this x and multiply it to everything in the other parentheses, what's x times x? X squared. And what's x times negative 7? Negative 7x. Then if I distribute the 7 to everything in here for my second distribution, what's 7 times x? Positive 7x. And what's 7 times negative 7? Negative 49. What happens to the inner and outer terms here? They're opposite signs, like terms, and they cancel each other out. So what's left? X squared minus 49. Couldn't we have avoided all of this work and just said right here, the first term is x, and according to the pattern it says square it. So do x squared minus, take the second term, which is b, and square it. What's 7 squared? 49. Couldn't we have avoided all that work and just done that? That's all I'm asking you to do, is to avoid your work and look at it differently. If you can memorize these patterns now, when we do Unit 9, the first part of Unit 9 will be so much easier. So much easier. All right, so let's do an example. Example 1. I just want to point out, by the way, that I was sick all weekend. And who's sitting here teaching you? Me. Do you know how many students I have absent? A lot. I don't think all of you have the flu. Now, granted, if you have a fever and you're throwing up, fine. Stay home. But if you're not, get to school. Find the product. So I've got 2 different problems in the same example. So the first one I want you to do on your own, based on what we just did, a plus 8 times a minus 8. Now I will let you know that they could have the minus binomial in front of the plus binomial. That's okay, it doesn't matter which comes first. So without any work, I want you to write down what the answer is to that. If you have to write the pattern above your work so you can follow the pattern, then you'll need to do that. For instance, you might want to write a squared minus b squared. So you remind yourself, oh, okay, this is a first term and this is b, the second term. So I'm going to take a and square it minus, what's 8 squared? 64. Done. So the only work that I might see is you actually writing out the factor pattern. For this one, you tend not to do it. For the next factor pattern, you probably will and should. All right, what happens if we have a more complicated binomial? What if we have 2x plus 5y and 2x minus 5y? Jack, can you do me a favor and close that blind there and see if it makes the board a little brighter? Good. Perfect. So again, you might put a squared minus b squared because you realize that it follows that difference of 2 squared factor pattern. And if this is my a and this is my b, what is this squared? You have to square the coefficient and the variable, so 4x squared is correct, minus, what's this squared? 25y squared. Done. Wouldn't you like to do that all day long? Well, okay, maybe not all day, but at least for your math homework, right? All right, so there's your first pattern. Your second pattern that we're going to look at today is a squared binomial. So a squared binomial is going to give you what's called a perfect squared trinomial. You are squaring a binomial and you will get what is called a perfect squared trinomial. There are two different patterns associated with this depending upon whether you have a plus or a minus. So this is what a squared binomial looks like. A plus b in parentheses, the whole thing squared. Now it's possible that you might see it written as a plus b times a plus b. Right? So you have to be able to recognize it either way. I'm telling you, and I'm going to prove to you in a minute, that the pattern works this way, that the pattern is a squared plus 2ab plus b squared. If there's a minus in the binomial, only one thing changes. If you have a minus b raised to the second power, it's still a squared, but the middle term becomes minus 2ab. So if there's a plus in the middle of the parentheses, the middle term is plus. If there's a minus in the parentheses, the middle term is a minus. But the last term is still plus b squared. So I'm going to prove to you that this works by taking x plus 2, and I'm going to square it, and we're going to do it the long way. So x plus 2 squared is really equal to x plus 2 times x plus 2. If you don't memorize the factor pattern, you will have to write out your binomial that way and then do a double distribution. So if I double distributed, multiply the x to everything in there, what's x times x? X squared. X times 2, everybody? 2x. And then when I distribute the 2 into the parentheses next door, what's 2 times x? Plus 2x, and what's 2 times 2? Plus 4. Now let me caution you before I explain a couple things. If this had been a minus here, wouldn't you have a minus and a minus here? Wouldn't this have been x times a negative 2? Wouldn't you have gotten a negative 2x? And then this would be a negative 2 times an x. Wouldn't that also be negative 2x? So if you have two negatives here, you're going to have two negatives here for your inner and outer terms. And then what's a negative 2 times a negative 2? Positive 4. So no matter whether you have a plus or a minus here, the last term should always be positive, and the first term should always be positive. It's a question of the middle terms. Isn't your inner and outer terms here exactly the same? And isn't A, this represents A, and this represents B. The first term in the binomial is A, and the second term is always noted as B. What's x times 2? Isn't that what this is, 2x? So isn't this A times B? And isn't this A times B? How many of those do you have? 2. Do you see why the pattern says 2AB? Because when you add them together, you get 2 that are exactly the same. Jesus? I can't hear you. Remember, my ears are plugged. It only works if you have a binomial squared. It has to look like this, or A plus AB times A plus, what did I just say? A plus B times A plus B, or A minus B times A minus B. In other words, the two binomials look exactly the same sign. Unlike the difference of two squares where they looked exactly the same, but you had different signs. So sometimes they're going to write it this way, sometimes they're going to write it out this way. You have to be able to recognize that if it's written out in exactly the same, it is that. So this one can be written two different ways, whereas the difference of two squares can't. Okay? Alright, so then our final answer to this would be x squared plus, what's 2 plus 2? 4x plus 4. So this would be our final answer. So if I were to use the shortcut, here's what I would have done. So let's apply the shortcut over here. I would have written out my factor pattern. Since this is a plus, I'm going to use this factor pattern. A squared plus 2ab plus b squared. Because this is the blueprint of telling you what to do. Square the first term, multiply the first and the second term together, and then double it or multiply it by 2. Square the second term. So what is x squared? Because a is the first term. What's this squared? X squared, right? And then plus, I've got 2 times a is x times b is 2. This you'll usually do in your head. You'll usually do it in your head. Doesn't that turn out to be 4x? So you get 4x. And then this is b, the last term. What's 2 squared? And again, that you'll do in your head. So I can go from here directly to here without any of this interim work. Again, this part you're kind of doing in your head. But for a while, I'm going to kind of write it out a little bit so that some of you who don't do so well at doing stuff in your head, you might, for these ones, write it out a little bit. It's your choice. All right, so let's look at an example. So example 2. Find the products. So the first one that you're going to find is 3y minus 5 squared. Let's make this a plus. I'm going to go ahead and make that a plus. 3y plus 5 squared. The first thing I notice is I only have one binomial, but it's squared. So this is a squared binomial. Immediately I'm going to write out my factor pattern. A squared, because you've got it memorized, plus 2ab plus b squared. I'm just going to follow that pattern. Again, you can write it out or do it in your head. It's your choice. For your note purposes, we're just going to kind of write it out a little bit. So I'm going to take my first term squared and add to that 2 times my first and my second term, and then take the second term squared. So what represents a? 3y is your a, right? And what represents b? The 5. So everywhere I see an a, I'm putting in a 3y. So here's a 3y. Here's a 3y. And then these two are b's. So my b is 5 and 5. All I have to do is perform the math. What's 3y squared? 9y squared. What's 3 times 2 times 5? 3 times 2 is 6 times 5. What is it, everybody? 30. Tack on that y. And then what's 5 squared? Done. All you're doing is following the pattern. So I want you to try the second one on your own. This time you have 3x minus 4 squared. It's a slightly different pattern. So write down the pattern and then follow it. See if you can follow it. So you're not worrying about signs because you're already figuring out the signs yourself with your pattern. Don't worry about signs. So you're not going to put a -4 in for B. You're just putting in a 4. When you get an answer, compare it with those around you. So talk amongst yourselves. Chat. Because everybody should have the same answers. So look up here. Here's your pattern. This time you've got a minus for the 2AB, right? Because your middle term is negative. So if you don't like doing it in your head, then use substitution parentheses. Instead of the A and the B's, you're going to use parentheses. It might help you for a while until you get used to doing it. So I put in parentheses here. I plugged in for my A's 3x, and for my B's the 4. What's 3x squared? Everybody, 9x squared. And then what's 2 times 3? Don't worry about the fact that it's negative. I already know it's negative. What's 6 times 4? So 24, and then tack on the x. And then what's 4 squared? 16. That's it. Done. Now this, eventually you'll be doing in your head. If you need to do that part on your homework, then you'll need to do that part in your homework. But that's essentially all you're doing today. That's it. You're following those patterns. Questions? All right, so I'm going to let you do your homework. I'll put the answers up here, and I'll come around and help as you